Geometric series example 2. In a geometric series, T3, so term 3 is equal to 32, and term 6, T6 is equal to 4. Find A and or, and hence, so just using what you've just found, using A and or, find S8, the sum of the first 8 terms. So we have Tn equals A times or to the power of n minus 1. So this is our geometric sequences nth term formula from the formula book. Make sure that you don't use the arithmetic sequence formula, which is also on the same page. So this is for geometric sequences and series. So we replace the n with 3 because we're told the term 3 is equal to 32. We'll come back to the 32 part in a minute. And we replace that n with 3 as well. So then simplifying, we get a or squared. So that's going to be equal to 32 because that's what they tell us in the question it's equal to. Then we're going to do the same thing with T6. So replacing the n for 6. So we have to the power of 6 minus 1. Simplifying, we get a or to the power of 5. And we're going to let that equal to 4 because we were told in the question that T6 is equal to 4. Now we're going to set up algebraic fractions that we can solve simultaneously. So we're going to have a times or to the power of 5 is equal to 4. So I'm choosing to put the highest power on top. It just means it'll be a little bit quicker to work out. And then I have a or to the power of 2 is equal to 32. So that's going on the bottom. So this is the bottom of our fractions because it's the lower power. I'll show you in a couple of minutes how we can work it out. If you put the lower power on top, you'll still get the same answer. It's just a lot longer. So now that we've set up our algebraic fractions, we can simplify. So we're going to cancel out the a's and we're going to solve for or. So cancelling out the a's and then subtracting the powers. So or to the power of 5 divided by or squared is going to be or to the power of 3 because 5 taken by 2 is 3. And 4 over 32 simplifies to an eighth. So solving for or, we're going to get the cube root of an eighth, which is a half, because a half times a half times a half is an eighth. So or is equal to a half. So the common ratio is equal to a half. Or if we decided to put the lower power on top, so we're still going to divide the equations. So we have a or squared equal to 32. So that's our numerator. So that came from up here. And the denominators are a or to the power of 5 and 4. So that came from down here. So we do the same steps, but this time we have a lower power on top. So we're going to end up with a negative in, say, here. So a or squared can be rewritten as a or. And a or to the power of 5 can be rewritten as a or. So we can see that the a's cancel and 2 of the or's cancel on both sides, on the top and the bottom. So we're left with 3 or's in our denominator. So we have 1 over or to the power of 3. Now, otherwise, you don't have to write this out the long way. I'm just doing that so you can see what's happening. Otherwise, we could have said or to the power of 2 divided by or to the power of 5 is or to the power of 2 minus 5, which is or to the power of minus 3. And or to the power of minus 3 is the same thing as 1 over or to the power of positive 3. And that is another one of our indices laws. But I just thought I'd write it out the long way so that you can see why it ends up to be 1 over or to the power of positive 3. But it's coming from one of our indice laws as well. And that, again, is in your formula book. You don't need to learn them off by heart. But the more that you practice them, the more likely that you will be able to do them by heart. So we're going to cross multiply. So we have or cubed times 32 on the left-hand side, and 1 times 4 on the right-hand side, or vice versa. It doesn't matter which side that they're on. I like to put the variable on the left just for solving purposes. So then simplifying, we have 32 or cubed equals 4. Dividing both sides by 32 to get the or cubed on its own. So or cubed is equal to 8. So or is equal to the cube root of 8 over 1 over 8. Which again gives us a half. So we get the same answer. So as you can see, much quicker to put the higher power on top. So we know that or is equal to a half. And we know that a or squared is equal to 32. That's from the previous slide. So we're going to sub in or as a half and solve for a. So to find A, we have A r squared equals to 32. So we could have picked either of the equations. It doesn't matter which one we pick. So replacing the r with a half, we get a half squared, which is a quarter. So a quarter, A equals 32. So A is equal to 32 divided by a quarter. So A is equal to 128. So we know A is equal to 128 and we know r is equal to a half. So now we're going to use A and r to find S8, the sum of the first 8 terms. So we write out our formula from our formula book. No need to learn it off. Replacing the A with 128, the r's with a half, and the n's with 8. And into the calculator, 255. So the sum of the first 8 terms is 255.